Ta-da. Thank you. As somebody who lives in the brutalist paradise of Geneva, that last presentation made me really sad for the architecture that I don't get to enjoy. I want to talk to you for about 20 minutes today about a project that we're working on that we've been building for several years, looking at connecting everybody in the world to the internet. Right now, there are about a third of the world's population, mostly poorer people, who are not connected to this thing which we take for granted in all of our life, and in the crypto life and in the real life. And one thing we've been working on for 6 years at Giga is trying to figure out how to get more people online in a safe way, and more people online into something that can help them kind of grow and be part of the digital future. And last year, here, not on this stage, but on the other stage, in the other place, I presented on where we were. This clicker does not seem to work. Can we go forward one slide? This clicker seems to be very, oh, may have to turn it on. That would probably help. Yes, that would definitely help. Yeah. Okay. Last year I presented where we were as Giga. I'm going to show you some data about what's happened in the last year, but I'm also going to ask you to think a little bit about what a marketplace looks like for connectivity. We have markets for oil, we have markets for wheat, we have markets for gold, we have markets for electricity, but this particular thing, this Gigabyte that all of us think about or don't think about but use every day, has no global market. Nobody knows what the price should be for a Gigabyte or even what a Gigabyte is. This is a map of Brazil. This is a map of Brazil a few years ago. So this is actually from 2019. And these are all the schools in Brazil. Every dot is a school. The green dots are connected to the internet. The red dots aren't. If you actually look at this map today, it looks different. There's a lot more green on the map. But you can see in 2019 how much of the country was not online. And that's data that we've collected. We've built the software for finding schools, finding hospitals from outer space, using feature extraction to create the largest map of those things in the world, those elements, and then figuring out how connected they are. In the last year alone, we've helped to connect something like 85,000 schools to the internet in 48 countries. So we've increased the number of countries that we're working in with ministries of IT and ministries of education, now ministries of health. And we've connected about another 25 million young people to the internet for the first time in their lives. I would invite you, if you'd like to explore this while I talk, go to maps.giga.global, right there. If you go to maps.giga.global on your phone, you'll see this map of the world. Any of the countries with red and green dots, forget the blue ones, but the red and green dots are live. You can click on those countries and you can see the schools that are online. You can't see health centers yet. Those are coming in the next month or so. But as we've been doing this work with countries around the world, we keep hitting this problem, which is that the Gigabyte, this fundamental thing which we use all the time, we maybe don't think about, but it's there, is priced super badly. In some places, it's 200 times more expensive than it is in the country right next door. Within a country, sometimes it's 20 times more expensive for one person than it is for somebody else. And in a place, in a time in our life when we maybe have an infinite data plan, we're not thinking about that all the time, we have Wi-Fi around us, but if you're in a rural area or if you're in a poorer country, the cost of this commodity is extremely high and actually prevents you from getting online. One of the things we've built, if you're looking at your phone and if you're at maps.giga.global, is this map. So this is an on-chain map of schools, of locations. Each of the ones that are blinking are giving us data every 4 hours about how much internet is coming into that place. That's what we call telemetry data. It's data about what's happening in that particular location, and it helps us identify and understand if a young person is getting access to the type of digital future that they need. If you're in a school that's green and it's blinking, that means you're getting pretty good connectivity. If you're in a school that's yellow, you probably aren't connected. I believe this may be one of the largest DPIN projects in the world. We're not in it for ego, I'm not trying to claim anything, but the fact that we're working now in 48 countries with the support of those governments, which is not an easy thing to do, with UNICEF and the International Telecommunications Union, and in all of these locations, I think gets us to some type of scale, which again, it's not a race, but I think it's pretty big. I asked Claude to make this before the presentation because I was like, I'm going to present on this stuff that I spend all of my life living right now, which is like, how does the internet work? But it's not necessarily clear to everybody always how the signal gets from this cable under the ocean or Elon's satellite to your phone. So just really quickly, this is the only diagram like this in the presentation, but here's your phone. And the only thing I want you to take away from this is that between your phone and the big internet, which is under the ocean, even the presentation didn't like my slide. Between your phone and the big internet, there are about 6 different other things. So don't worry about the exact pieces of the slide, but just know that between here, where the internet kind of originates in every country, whether it's there or in the ocean, there are about 6 different entities that in some way touch the gigabyte that goes onto your phone. And none of them talk to each other right now. So the point of this slide is just to show you that this is not an easy system that goes from a cable to your phone. There's a bunch of different people, and all of them have different pricing for this one asset. And in fact, many of them call it different things as it flows through their systems. So what we've been trying to do over the last 2 years now is to build the first ever marketplace for connectivity. And I'm excited that we're doing this with the support of the Ethereum Foundation, with the support of many of our friends in the technology space who look at how to increase the number of people who have access to this resource, which we all use, but maybe we don't think about all the time. And if there are these price differentials of 70x or 200x between countries and of 20x inside of a country, one of the ways to get better pricing is to have a marketplace. Marketplaces are generally good for creating price transparency, for understanding how much a thing is actually worth to somebody. And right now, if we think about this complicated thing, here you have a bunch of people every 5 years with wooden paddles in their hand bidding on the price of that commodity. And here you have operators who tell you on a text message that your pricing plan is going to change. So there's no consistency across all of those different layers. The way that we're trying to build this marketplace is to look at how you validate whether or not there is connectivity in a place, that's the blinking dots, how you understand the price of that commodity, and then how you allow people to trade it. And this is pretty fundamental if anybody's working in other markets. However, in this particular class of assets, it's never been done. One of the reasons is that it's hard to figure out where the demand is coming from on something that's sold a little differently in every country, that it feels like it's a different size or type of thing in every country. It's also hard to understand where the resource is coming from. So we just heard that there's enough stone in the ground for the next 50 million years. We know where oil comes from. We sort of know where electricity comes from. People don't really think about where a gigabyte comes from, and it comes from networks, and networks are really hard to get pricing for. And then we also don't know when things are being delivered. If you are at home and your internet goes out and you load up, speedtest.com and you take a screenshot of it and you send it to your internet service provider, maybe something happens. But people don't really know how that contracting cycle works. If you buy 1,000 tons of wheat and you get bad wheat, you sort of know how to adjudicate that. The marketplace that we've set up in the last 2 years has the following types of players, and it's not important exactly who they are, but on the settlement layer, everybody from governments, like government of Mexico, to specific groups that provide community internet are helping us do the settlement side. We have big mobile network operators helping with the pricing, and on the validation, we've built a lot of technology with the support of companies who are interested in getting more internet out to the 1/3 of the world, to the 2 billion people who don't have it. And this is not a global marketplace yet. The problem with this is that many of these are clustered in a few countries, which I'll talk about in a minute. But it starts to show you a picture of who the actors could be if you had a global ability to exchange this commodity in real time. One thing that's exciting is that it starts to, as we understand who's selling the commodity, it's the internet service provider, it's the satellite operator, it's a cable provider on one side, and who's using it, it's a school, it's a hospital, it's a government who's buying a lot of this service, we start to get pricing information for how much that gigabyte is worth. This is not something that exists at a global level in any sense right now, which makes you wonder if you're building a data center, and a data center, everybody's talking about data centers now, data center needs to have electricity, a physical area, and it needs to have connectivity. And if you don't know what the price of connectivity is going to be in a country in 3 years, how are you getting the pricing for your data center? How are you coming up with that valuation and the financing and building the project finance? And that's a good question. I would ask that as I think about the crazy AI market. But so we're starting to see spot prices for this asset, for this commodity, in a way that just never happened before. And I'll give you 4 examples of how that seems to be working. In Mexico, we have on a buy side, we've got the government providing a set of options. On the sell side, we've got satellite capacity and now internet service provider capacity. In Malawi, the government is, as what they're providing to the marketplace is a tax break. So they're saying, if you connect these schools or these hospitals or these other places, we'll give you a tax break if you provide us with a set of tokens that prove you've connected them. The providers are then translating those, they're translating their tokens for either tax breaks or satellite capacity. In Kenya, we have fiber optic cable providers who want to see the proof that their cable is being used for extending the internet to new places. And so the credits there are kind of fiber capacity. And in South Africa, there's a big debt fund that invests in small service providers in the edge markets who is able to take the credits that are generated and are minted once a school or hospital or post office is connected, to take those credits and turn them into a better credit rating for companies that their debt fund can invest in. So in each of these 4 markets where we're piloting this project, we're testing different capacities. And the interesting thing is, in the last year since I was at ETH Prague a year ago, we've sold about $1 million worth of these credits in these 4 countries, which means that there's something happening, that people see a value in the marketplace, which is kind of neat. The way that it works in 3 slides is that, first of all, we do some validation. So in a school or a health center or a post office, each of those objects is an NFT, by the way, so it lives on chain, and the data is updated. I'll come back to that at the very end, but it's kind of a neat feature of this system. But in that place of action, in that 140,000 item network, we have a piece of software that's monitoring school connectivity. And the first step is to make sure you have that validation that the service has been delivered, that the wheat has gone where it's supposed to go, or the oil has gone where it's supposed to go. The second thing is to get the pricing, to know how much that's going to be, that's going to cost. Once you see that the school is online and it's an item there in that marketplace, the service provider can look at it and they can see if it's worth it for them to connect the school. If they do connect the school or the hospital or the post office, they get some number of credits. And that allows them, they make a choice, the way that an Uber driver makes a choice to pick up a fare. If it's worth it for them, that's not a great example because the algorithm is so disgusting, but imagine that worked in like a nice way. In a non-disgusting algorithmic way, the service provider gets to see if they connect these 5 places up on that mountain, they get a ton of credits, but maybe they have a fiber optic cable that already goes there, so it's quite easy for them to do it, and so on. They get to make their own choice. We get to see the pricing out of that, which is very interesting, because again, if you have a commodity with no real pricing data for it, you have no ability to build a marketplace long term. And the last thing is that we have a settlement layer where we can connect the people who are doing the connectivity of schools or hospitals or post offices with the people who are paying for that to be done. The people who are paying for it to be done are either governments who want more of their population to be online, or there's service providers, there are other kind of companies that want more users. So these could be big hyperscalers that are like, I want more people to use my stuff. They can be over-the-top services, things like YouTube, who want people to watch their things. They could be frontier labs who want more eyeballs for the creepy stuff that they're doing. Whatever. There is a vested interest in getting a third of the population into an environment where they can be online. And we're able to make that exchange happen so that once the credits are there, they can be redeemed for some of these incentives. Just to show something that's happening in real life right now, in Mexico, one of the problems is that while schools are generally connected well, I mean, they're connected, they're not connected well, they're connected very slowly. The speed of the average speed of a connectivity in a school in Mexico is about 10 megabits per second. And nobody really, my guess is that very few people in this room have experienced 10 Mbps recently for any sustained amount of time. Like, you may have experienced 10 Mbps on a call and it got a little bit jittery and you're like, I have to move to another part of the house. But you haven't lived with 10 Mbps. It's a very small amount of internet, and it's a very small amount of internet for a school to have if you're trying to get 3 or 4 people to have a Zoom call at one time, get somebody to do telemedicine in a health clinic. So really the capacity of the networks that are built there are not providing enough of this resource to the people who need it. As a pilot, 3 months ago, we connected about 75 schools in Jalisco State. We told those service providers, if you connect this school, if you take this school and you turn it from red to yellow, so if you look at maps.giga.global, you'll see that there's a yellow and amber level in the middle, which is like It's connected, but it's not that well connected. If you connect it from red to yellow, you get some credits. If you connect it from yellow to green, which is the best level, you get more credits. And we were able to start seeing the traffic flow through for about 75 schools. Starlink was the backhaul provider there, so Starlink took the credits from the service provider and gave them more backhaul from Starlink, allowed them to use more of their network, which that service provider can take and sell to other people and make money on. So they connect the school, the health center, the public building, the post office. That thing doesn't have to pay. The service provider makes their money back from retail users. Starlink, in that case, gets more customers. They get a sense of what's happening, and we get all this data about market, what the market will support, and who's using it. We're about to, now that that's been successful, and we've shown that there's a little bit of mobility inside of the old structure, we're scaling it up to about 300 schools in the next 2 months, and then it'll go to about 3,000 by the end of the year. It's small, so 3,000 out of 160,000 is like 1% of the schools, a little less than that, less than 1% of the schools. So more than 1% of the schools, but it's not going to make a huge dent, but it shows when you have about 2% of that, connectivity stuff happening, 0.2%, then you start to get really into something that the government can use as a model. When we go up to the 3,000 schools, we're bringing in the 6,000 internet service providers in Mexico to be on that marketplace, which means that we're going to start to see, and in addition to Starlink, which provided some of the backhaul for the first one, we're able to use other fiber optic cable providers to provide that incentive to these service providers. And this is happening in the other 3 countries that I described as well. So I wanted to show this as an example of how in one specific country the marketplace starts to get stood up. I think it gets more and more exciting the more countries you connect together. And the fact that it's all built on Ethereum is kind of neat. Like the fact that we're using a set of primitives from locations, which are NFTs, to smart contracts for payment, to a marketplace which matches people and has identity in it, I think shows that the stuff that we've been working on for years actually has real world utility. That's nice. But also shows that you can use the fundamentals of a permissionless blockchain to scale something across multiple markets. And so that's really the next step, is seeing how this moves. I mean, once it happens in one country at some scale and then another, how you connect those two. What we're looking for the next sort of sector, and one of the reasons that this becomes what I think is a very interesting DeepIn project, is that everything I described is contingent upon validation. You need to know that this commodity was delivered. And again, with like a regular commodity, you can kind of tell that it's there. With the electricity, the light goes off. People don't always monitor or meter their internet in a very good way. But there are a lot of smaller DeepIn projects, everything from figuring out weather temperature and being able to tokenize the device that's up on top of your building and get some tokens for being part of a weather network, to on-the-ground GPS sensor technology, which replaces the existing GPS system with something that's more accurate, for example. Those types of DeepIn systems all need the networks that we're building to be extended to 100%. They cannot work in a world where a third of people don't have that network. And so one of the most exciting things over the last few weeks has been that we're starting to pull together smaller physical network providers, people who are working on sensors that need connectivity as an underlayer, and asking them to run the firmware that we've built to help us monitor the access and the quality of service levels at those locations. And in return, we say you can use the school as a center, as a place for, as a place to dock your physical thing. So one question is, we're very interested in speaking with DeepIn projects that need a physical location and some connectivity and are working in the markets that we are. The second that I'm quite excited about is that, as we've shown in Rwanda, where we're staking a few nodes worth of ETH and using the proceeds to pay for a few schools' connectivity, we've shown that we can stake, and thanks Ethereum Foundation for that support as well, we've shown that we can stake assets, that the assets don't need to sit with us, and that we can use revenue generated from that and proceeds to actually go into smart contracts and automatically pay vendors. I believe that there's a chance to show this at a much bigger level, and so we're about to start our discussions with big stable providers and others in the crypto ecosystem about building a larger pile of staked assets to where the yield from that will go to pay for connectivity. And then finally, as I mentioned, we've got all of the schools that you saw on the map are NFTs. They're all on testnet right now. We do believe that those should be minted. Those should be minted on a mainnet. And so we're looking for L2 providers who would want to help with the minting and sustainability of that. That particular piece of architecture, like a school in northern Botswana does not have a web page. They may not even have a postal address. They certainly don't have like an Ethereum address, right, or anything close to a wallet. But the fact that we'll be able to hold these in escrow and to start making payments to those institutions over time, I think gives us another example of how when we build across all the different parts of the DePIN spectrum, you can have something that really does have an impact in the world and also creates markets that didn't exist before. Thank you so much, and I really look forward to talking to you all after this conversation.
Thank you very much. We would have time for one quick question, if anyone wants to ask a question. Well, lucky me, I have one for you. My wife's family has a tiny vineyard of 4 hectares, and we're actually building like an open source tracking device for like weather, wind, insects, and stuff like that. How would something like that integrate into what you just described?
It depends how connected it is right now. Like how
it's online and like pushes the data into like weather networks and stuff. Yeah.
Yeah. I mean, as the software that runs in the 140,000 schools and health centers is like 180 lines of code, and it's a Chrome appliance. There's going to be a firmware version of it also. So that could just go into, you know, any other physical location, and into if there's like an Arduino or a Raspberry Pi, it can go on that, or it can be bolted on if it's a router, and then it would just start to give us telemetry data. So you'd be a dot on the map. It would start blinking, and we're not trying to like depin that. I mean, that's still your thing, but at least we'd be able to see what's happening, and you'd be contributing to a better marketplace.
Cool.
Thanks.
Fantastic. Thank you so much, Christopher, for being here.
Thank you.
Next up, we have Peter Szilágyi.